We're discovering that irreversibility, as opposed to putting a lot of energy into ordering things, the irreversibility of reactions is what's keeping things going in a forward motion. Much like, let's say, this ratchet or come along here. We're suggesting that once something happens and it ends up in a configuration of least entropy and more dissipative configuration is the forward-moving motion of life in general. But we're going to get deeper into how exactly that works. Furthermore, he says that when we're at most statistically irreversible, that arrangement is the one where we're able to absorb and dissipate the most work. So again, we're feeling this forward-moving movie of lifelike things being able to dissipate and produce more energy with time. So we're saying that they found some mechanism where this happens, which I think is completely exciting. It's life-changing. I don't think it made front page news, but it's going to be our missing link and what we've been looking for, this missing piece of the puzzle. And so in this way, we're going to be able to explain the emergence of life using fundamental physics. So that's our Holy Grail. That's our goal here today, is to be able to see how that works and maybe to take it one step further in modeling it and to see exactly how it happened. So in explaining or showing the mechanics of how what we just said occurs, Jeremy England invites our old friend Svante Arrhenius, which his works, he also had fancy formulas, but his works involved activation energies in chemical reactions. So let's go ahead and take a look at some very basic chemical reactions, arbitrary. So we're saying that we have things that go from A to B, let's say, or B to A. And so these could represent microphases, macrophases, or chemical reactions going from more concentration, less concentrations. And this would be a reversible reaction at equilibrium, where the certain energy or temperature of a bath combined with what is being, the energy that's being produced, we can actually know based on these parameters what the proportion or ratio of the probability of one phase or one concentration of chemical reactions would occur, because they are what's called Boltzmann distributed. So this is known, this isn't new. And so at equilibrium, which we touched on the fact that life is not at equilibrium, it's anything but equilibrium, it's far from equilibrium, because there's a lot of dynamic things going in it. Equilibrium means death. Equilibrium means you've got a pile of stuff that's just sitting there and it's done. It's not moving towards evolution. So at equilibrium, we've got this scenario here. So Svante Arrhenius and his equations, we're talking about activation energies. So let's say there's a certain activation energy to go from A to B, and it's kind of low, and so we're able to go back and forth because there's nothing changing that. Let's imagine, let's say a match, lighting a match. So the activation energy would be when we have enough heat and friction to go from just an unlit match to a fire. And that's a big activation energy to get over. And also it is irreversible. So once the match is lit, that fire is going to reach a new height and it's not coming back. Not because it necessarily couldn't, it's just that the probability of it is just so astronomical that we've never seen it. So in a non-driven system, we have A to B, B to A. If we start driving this system, which means that we're applying some kind of a oscillation or modulation or changing the energies. We're moving it, we're driving it. It could be an engine or a motor. Now B would go A to B, B to A normally, but now we have the opportunity of possibly, by driving a system, to go from B to C even. But in this case, we have a high activation energy. Let's say it's the lighting of a match. So this is an unlit match going back and forth somehow. And yet, and at some point, if we're able to have this activation energy, we're able to overcome this activation energy and turn into C, which in this case would be the match. So the big point that we're trying to make with Gavin Crooks and Jeremy England is that we're not saying that it's more probable that we're going to strike a match or arbitrarily hit that activation energy of anything else. But once we start oscillating things, once we start changing the energies in a system, once in a while, we're able to overcome an activation energy. So this would be the ratcheting of our system here. We're able to go over it. And the reason, and in this state, by the way, we've increased the entropy, right? The energy, the potential energy of the match has gone out, and we've hit a lower internal state of entropy, but exhumed a lot of heat and work. And the reason we stay in this state is because once that energy is released, we're not going back here to be. It's irreversible. And this is the mechanism we've been looking for. And I'm going to dwell on this. We're going to give a bunch of examples of this concept, how that works, where we're saying that because if we're driving things, we're pumping it full of energy, we're doing stuff to it. There's thermal vents and ocean currents and winds in primordial earth, and there's a lot going on. And the reasoning we are ratcheting ourselves towards a state of producing more and more entropy is because as we hit new activation energies, we're not going back. And the end state, the state that's going more and more towards a living thing, is the one that stays because it's not going back, because we've produced all of this entropy. This is mind-boggling stuff to me, and it was that Holy Grail, that missing link that we've been looking for, in my humble opinion. Maybe not so humble opinion. But this gives us the opportunity that we have A, B. Now we might go to C. Now this gives the opportunity to go from C to D with a new activation energy, a new set of parameters, where now we're stuck in C, right? There's this big activation energy, but everything's moving around with everything going on. And once in a while, not always, not most probably, but once in a while, we do go over this hump where new energy, new configuration is producing more entropy, and it's not coming back. And that is why we see arrangements all around us that are as they are, because they're not going back. We have that forward moving motion of entropy. So that's the idea that we're moving forward with. And it's so huge in my opinion that I'm going to attempt to give practical, human, everyday examples of where we might see this. So I'll start with a vending machine example. So most of the time we put our money in the vending machine and our bag of chips falls. 95% of the time, maybe 5% of the time it does not fall. So at this point we have a choice. We can either put in more money and hopefully get 2 bags of chips, or we can apply a field to the vending machine, right? With our fists and with our bodies, we can bang into it, and maybe at some point we hit that activation energy where the bag of chips falls. And at that point, it doesn't fall back up. It's done. The reaction's finished because we applied a field to it. Another example would be, let's say you have a big jar or bag of change that you would like to turn into cash. So you go to this machine at Walmart or whatever, and you dump your jar of change onto this tray, and you sit back and watch, and nothing happens. It just sits there. until we apply a field to it. In this case, we're moving the platform back and forth, and there's this wheel that's turning with different size slots in it. And as that happens, as this modulation, oscillation occurs, these applied fields, the coins find their correct spot. They lower their internal energy to a state of lower entropy where they're neatly stacked piles. And as a result, all the energy gets turned to kinetic energy, different forms of heat and work. So now we have the optimal configuration being a very ordered state and maximum entropy. And the coins are not going back. So that's another example of what we're talking about here, this ratcheting, this going in a direction of higher dissipation, higher entropy, and as a side effect, having created order. Another example, as we try to relate this to everyday activities, let's say you've loaded up your pickup truck after a garage sale or a flea market, and it's full of furniture and different items, and you want to make sure it doesn't fall off to the road as you drive. So you tie it down nice and tight. You can even use ratchets. And you might make it home, or you might stop a few miles in and check on your cargo and realize that, wow, you could tighten it up a little bit more, because with the applied fields of the road and the suspension and things happening to all these things, we've hit naturally lower states where increased work and dissipation is the output, but we've gotten to a lower, more ordered state, to the tune where now we can actually ratchet it up a little bit more and tighten it down a little bit more. Another example would be if you've ever heard of a sushi conveyor belt restaurant. And so when we look at this, we've got people sitting down and there's a conveyor belt with food on it that people can grab. Now, if we were at equilibrium and not driving the system, you'd have all these people sitting down and the conveyor belt would be just sitting there. So this is a configuration that would not be optimal for the customer or the business. It would kind of defeat the purpose, where the people would have the opportunity to pick from arm's distance what they like, and maybe it's what they like the best, probably not, probably it's something they'll be okay with but not prefer. And in this state of equilibrium, it's actually reversible in the sense that, I'll take this, maybe I'll take that, I don't really care, I'm not too excited, I'm not going to shell out the most money, and the business is not going to do its best. This would be equilibrium and nothing really happening, which is not how it was designed. So now we turn on the conveyor belt, and now people can wait and see and choose and pick and decide to their favorite thing. Now I can get exactly what I want, pay the most for it, the business does its best, because we've applied this field where things are allowed to connect to the point of most irreversibility, right? When we've chosen what we like best, we're less likely to give it up. And so we have a scenario where maximal dissipation or entropy or money production in this case occurs as a result of naturally applying a field to it. So I hope this is starting to make connections and sink in. We're seeing a trend here towards applying a field. Again, we're shaking it up. We're moving things. And when we do, things are happening in the sense that maximum entropy is naturally occurring and not coming back from. And so maybe at this time we can talk about the elephant in the room, where it seems like we might be close to talking about what we might refer to as intelligent or intelligent design, where the big mystery is, how does that Boeing 747 occur? How does beautiful life emerge if there wasn't some hand or magic or some such thing being involved? And so when do we as humans say that something is intelligent or that an intelligent hand is involved? We see something that's very well designed. It's aesthetic. It's well formed. It's there. And we look at nature and we look at these beautiful complex animals and we're like, wow, man, that's really amazing. There's intelligence behind it. And here maybe controversially so, we're suggesting that this intelligence actually refers to the most efficient or entropy producing or most dissipative configuration, which occurs actually as a natural side effect. So the body or the form that we see is actually the end result. It's our change being nicely stacked after the end result of maximum dissipation with most irreversibility is involved. So as long as we're here, we're going to go one step further and talk about how this is involved in humans. So let's take a look at, for example, relationships between humans. Or let's say you need a job and you want to find just the right job. So I'll present to you this analogy where if we're at equilibrium, if we're not really dating different people or applying for jobs, or the job isn't selecting and interviewing people, then there's an equal chance that you'll just end up with whoever and that you'll end up with whatever job it is. And similar to the sushi restaurant conveyor belt example, you'll get to a point where it's like, yeah, it is there, it's settled down. It's very reversible because you didn't really get to pick and choose, and so nobody really cares, and so the business doesn't make the most money, and the people aren't as happy as they could because they haven't applied a field to it. And the field that we would apply, if it was an active non-equilibrium scenario, is that we would date different people, try out different people, and similarly we would apply for jobs that might be most conducive to our attributes, and similarly the business would interview people that are most apt to be the right candidate. And the end result of this applied field to the right conditions, right, we're moving, is that you'll have the strongest or most irreversible relationships after the right match has been made. So in humans, it refers back to survival and reproduction and maybe money. And for the business, same thing, maximal money, the best connection between the right candidate and the job description. The more irreversible it is, the stronger it is, the better the company and the person does. So we're seeing this trend going all the way across the board, what we may have called intelligence, right? Because now we're seeing this thing making sense, going in a direction where the end result seems intelligent or best case or most efficient. Let's see where that takes us. So our goal now, our challenge, is to be able to model or demonstrate how what we've learned today could show the origin of life using the pre-life parameters of Earth in a way that's we can go full circle with it. So one way would be to demonstrate with computer modeling. I'm sure people have tried that or have done it to some extent. I don't have that resource here. So what I set out to do is design and build miniature micro robots that would represent the simplest form of life possible, which would be an A and B switch that is reactive to different modulations or sources of energy. So the way these are built, so I came up with these little guys called arbitrary dissipative automatons machined as non-Darwinian evolving virtual engines. And maybe I should shorten the name or come up with some witty acronym. Maybe you guys can help me in the comments below. And these, the reason I've chosen this configuration is that they're made out of two materials only. One is 3D printing filament, and the other is a special metal alloy called nitinol that has the properties of superelasticity and shape memory. As a side note, it is rumored that this metal was found around 1947 in New Mexico near Roswell, but that's just a fun rumor. I don't think that's really true. The idea is to combine these two materials and today I would like to propose to you a new theory and working model on the origin of life. To be at that evolutionary state, I'm in just the right lightning bolt to come in. With this model, we're saying that